Okay. Apparently it is a product. I don't know. I'll have to look. During deep sleep, a person's breathing can be very irregular. The volume of air in the lungs follows a sinusoidal relationship that varies from 1,000 millimeters to 5 milliliters over a 5-second interval. So what's the period?
10 seconds.
Yeah, so I mean we're talking about if it goes from 1,000 to 5,000, we're talking half a period, right? So the period is 10 seconds. Okay, it's always good to figure out. Sketch a graph representing the volume as it relates to time. If at the moment the person enters deep sleep, the volume of air in the lungs is 3,000 milliliters. Okay, so here's 1,000, 3,000, 5,000. It says sketch graph representing the volume as relates to time. Of course, there's deep sleep at so we go up to here, down to here, and so on. So we have our midline. We've got our max, we've got our min. If it takes 10 seconds to run through a complete period, then how long does it take to get up to the top here, to the maximum? 2.5. Back here, 5. Down here, 7.5. And then back to the starting point is 10. Okay, so that's our period, right? So it took 5 seconds to go from 1,000 to 5,000. So we went back here, so it would be 12.5. So we'd be talking about 7.5 to 12.5, right? To go from 1,000 to 5,000. Yep.
Why would the graph start at 1,000?
Called read the question. Comes in handy on tests as well. Now, from a practical point of view, why would we start at 3,000? So you could do a nice unshifted positive unshifted sinusoidal function, right? I mean, when we actually go to determine the equation, right? We get a nice, it's positive. Okay, so D is equal to max plus min over 2, the max plus the min. So 5,000 plus 1,000 over 2. I guess this actually comes into part B, right? We're determining the equation. So that's 3,000. A is max minus min over 2. So if you ever have to algebraically determine, then this is what you'll be showing. So that's 2,000. Okay. I mean, we can get that off of here, right? I mean, D is 3,000. And A is 2,000. Okay, but it says determine, so that's showing work. I mean, here's a nice little formula for that. What do we say the period was 10 seconds? So what's that mean that B is? B is 2 pi over 10 or pi over 5. Okay, so if we do this, V of t, volume, with respect to time, is equal to 2,000, it's my amplitude, sine pi over 5 t, and that's it, right? Because it starts at the midline going up, then I can do it as a positive, unshifted sinusoidal function. So 2,000, blah, 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 plus 3,000. Okay. You could do it as a cosine function, a positive cosine, which would give you bracket t minus 2.5. You could do it as a reflected cosine, negative 2,000, then it would be t minus 5. You could do it as a reflected cosine, although you'd probably go this way because it would be, that would be negative 2.5. So as a reflected cosine, the minimum phase shift would be to the left. Okay, but, you know, so I think if you get to set it up, then you get to choose, right? It's like, hey, this works out very nicely as an unshifted sine, and it's good. You know, it's less First falls into a deep sleep at exactly 1 a.m. Then algebraic determined the volume in the lungs at 1:10 a.m. And how much time will have passed? 10 minutes. But what do we need our time in? We need our time in seconds. So 1:10 minus 1 a.m. is 10 minutes, which is how many seconds? 600 seconds. So we want to do V of 600, right? So the volume at a time of 600 is 2,000 sine pi over 5 times 600 plus 3,000. 120. So 2,000 sine of 120 pi So what's the sine of 120 pi? What's the sine of n pi, where n belongs to the I? What's the domain of sine? Actually, it's just all real numbers. Sorry, what would be the... Okay, anyways, 120 pi is a multiple of pi. All multiples of pi for sine are 0, right? Sine of pi, 2 pi, 3 pi, 120, 0 pi. So it's equal to 3,000, right? So sine of 120 pi, okay, maybe we put that in there. So it's 2,000 times 0 plus 3,000, which is 3,000. Also think about it, if the period is 10 seconds, this is just 60 periods, right? So 60 periods is going to take you back to the spot you were at. You've gone through an even number of them. So 3,000 milliliters, right? 3,000 milliliters. Okay, is there more? Yep, so that's it for that one. Yeah, so everybody's good? So figure out your period. Figure out what information you're given. Where am I starting this thing? If they don't tell you, then you can arbitrarily pick a start point, right? Small toilet holds a slinky and lets it oscillate up and down. So instead of dropping it, right, which is far more cool, they're doing this. And in full expansion, so the bottom of the slinky will be a foot above the ground, and then it's going to compress, going to come up, be 3.5 feet, go down to a foot, up to 3.5. Determine an equation relating the height of the bottom of the slinky to time if at t equals 0 seconds, the slinky is in full expansion. Okay, so how high will it be at time 0? So here's time 0, and what are our big numbers here? We got 1, then we got 3.5, and then what's halfway? 2.25? Okay, I mean, I guess we should calculate it, right? We'll go calculate those, but so slinky's in full expansion and full compression. So it's at full expansion. When it's expanded, then the bottom is 1 foot above the ground, and at full compression. And how long did this take? It's at full compression 3 seconds later. It's kind of a slow slinky. Gonna put my midline in there. What's the period? Yeah, so the period is 6. So this will be 1.5, 4.5, 6, etc. All right, so D is max plus min over 2. It's the average, which is 3.5 plus 1 over 2, which is 2.25, right? 4.5. A is max minus min over 2, excuse me, which is 3.5 minus 2.25 over 2. Or it's like, how far is it from 1 to 2 1/4? Let's go with 1 1/4. Okay, so we got our D, we got our A. Yeah. Oh, it is minus 1. Got the answer right, so it's wrong. So that's 2.5 divided by 2 is 1.25. What did we say period is what? Okay, so the period is 6 seconds, so what's B? Pi over 3. Okay, 2 pi over 6 or pi over 3. Algebraic determine the height of the bottom of the slinky 7 seconds. Oh, we need an equation, right? Determine an equation. What kind of equation would you like? I'll take a cosine, okay. What kind of cosine? A reflected cosine, right? Okay. So you could do this, right? I mean, I guess if you can, look for an equation that doesn't have a phase shift. So in this case, hey, it's starting at the bottom, so that would be reflected cos. So y is equal to negative 1.25 cos pi over 3 your equation, t seconds is height or something. Y, so we call it h maybe for height, h of t. Cos pi over 3 t, and then plus 2.25. You could also do this as a sine, right? So it could be, or h of t is 1.25 sine. What's the phase shift? Right, 1.5? Oh, right, minus. See, I was right the first time. I was writing minus. Yeah, t minus 1.5. How many equations can you come up with? 4. Right? So this is a positive sign, so if you just like, hey, I like sine theta better than anything else. Or it says algebraically determine the right, y equals a sine b, blah, 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 where a is greater than 0. Okay, stuff you need to pay attention to in questions on a test. They want a to be greater than 0, less than 0. Do I have full choice, right? Just determine a sinusoidal equation. Okay, here it is, right? That's what I'm going to go with. Determine the height of the slinky at 7 seconds. Okay, so to the nearest tenth, h of 7 is negative 1.25 cos pi over 3 times 7. I like to write that as 7 over 1, just so that I make sure I end up with 7 pi over 3 and don't end up with the 7 on the bottom or something. Plus 2.25. So negative 1.25 cos 7 pi over 3. Well, that's the same as pi over 3, right? Because 2 pi is 6 pi over 3, so 7 pi over 3 is just 1 pi over 3. The cos of pi over 3 is 1/2. Okay, so we don't need a calculator there. So negative 1.25 times 1/2 plus 2.25. Maybe we do need a calculator. What's that going to be? It's going to be like negative 0.675 or something, and then 2.25. Okay, what's it work out to? 1.625. Round to the nearest tenth, so let's go 1.6 units. What was it in? Feet. Fit. So 1.6 fit to the nearest tenth. Graphically determine when the slinky first reaches a height of 2 feet above the ground. Okay, so graphical, what do we got to do? Yeah, so it says graphically determine, so we need to show, right, here's the work I'm going to do. y1 is equal to negative 1.25 cos pi over 3x plus 2.25. y2 is 2. My window is, so I wonder when it first reaches 2. I don't have to go that far, but let's at least show one period. So say we go 0 to 6 and 0 to 5. So 0 to 6 by 1s, and the y's, 0 to 5 by 1s. Okay, so let's just get a calculator out. Y equals, so this will be in radians just because it opens in radians. cos pi over 3. I just like to throw that in brackets because I guess you could enter it as a fraction too. Plus 2.25, and the window says 0 to 6 and 0 to 5. And I need to know when I hit 2 seconds, so y2 is 2. And hit graph. So we should just be seeing one cycle, right? One period. We went 6 seconds, which is one period. Okay, and there's when it first reaches, okay, rounded to the nearest hundredth, second, calc, intersect. And I'll hold for more than 3 seconds. 1, 2, 3. So 1.3, what is that? 1 point, is that a 0 or? 1.31. Okay, I can see. So if we want to, we can also sketch this out. So here's what we're looking at. Okay, so let's find the x-coordinate of the point of intersection. And what is it? The slinky, so that's what we're doing. The slinky first reaches 2 feet. Reaches 2 feet above the ground. At a time of, it says 1.31 seconds. Okay. Okay, so if they're going to give you some information, sketch it out, figure out the period. They might be giving you a full period, they're giving you some information which will allow you to calculate the period. It might be a quarter of the period, it might be a half, it could be 3/4, it could be 2/3. As long as they give you some fraction, then you can work out what the period is. Then you've got exercises here related to that stuff. Okay, and I don't believe this stuff is on the cue, so that's just for you.